So this is the first page of Unit 2, and this unit, the beginning, is focused on factoring. So basically in algebra, there are certain skills that are called gateway skills, or skills that you basically have to do to try anything harder. Factoring is a big one of them. So factor, we see two different definitions. Factor is something we do, or a verb, and it means to rewrite a quantity as an equivalent product. Factor as a noun is any individual component of that product. So we're going to look at just factoring integers first in exercise 1. And we're going to factor them as much as possible down to prime numbers, which is called prime factorization. So for example, with the number 12, I can pick any two factors of 12 to start factoring it. So for example, maybe I say 6 times 2. I could do 3 times 4, right? 1 times 12 is not really going to get me closer, so I wouldn't pick that pair. Then I look individually at the 6 and the 2 and see if I can factor either of those further. 2 is already prime, so it's done. But 6 factors into 2 times 3. So this is completely factored. We have our new 2 times 3, and then we have the original 2. I could rewrite them from smallest to biggest. I don't have to, basically, but that is completely factored down to its prime factors. So with the number 30, maybe I pick 5 and 6 to start with, or 3 and 10. I'm going to do 3 and 10. And then the 3 will stay, and the 10 further factors into 5 times 2. We can leave it like that, and I'm just going to show one of them if we put them from smallest to largest. That's also a common way that you'll see it. So why don't you try 16 and 36? You can pause the video and then come back and check those prime factorizations. Okay, so the number 16, I'm going to break down into 4 times 4. And then each of those 4s breaks down into 2 times 2. So we have 2 times 2 times 2 times 2. 36 also breaks down pretty far. Sorry, this is going to pop in. Hopefully, we might get another smart notebook that pops in, but we're going to close it if not. So 36, I don't know. Let's try with 9, or start with 9 times 4. So 9 times 4. Sorry about that. 9 is 3 times 3. 4 is 2 times 2, and that's as far as we can go down. So that's factoring integers, and that's definitely a piece of factoring when we get to factoring expressions with variables. But we also have to think about how we factor with variables, and then also we're not breaking down individual numbers, we're looking at all the terms in an expression. So moving down the page, this type of factoring, the first type we're going to try with variables, is factoring out the greatest common factor. So when I look at an expression, I'm not breaking down the 6, for example, into 2 and 3. I'm looking for something that the 3x squared and the 6x share in common, so I can factor this. Basically, if I want to factor, I want to have multiplication. I can't have this addition connecting 2 terms. I want something times something else. And one of those things could be in parentheses, but that's kind of our goal. So looking at the 2, for the numbers 3 and 6, I have a 3 in common, so that's what I would take out. And our rule for variables is basically we look for the lowest power of the variable that's in all the terms. So in this case, my lowest power is x. So we don't really take all these steps because this is, a big review topic. But my GCF, I could write on the side is 3x. So I divide both terms by 3x, leaving me with an x in my first term. The x's will cancel, and I'll just have 2 in the second term. And then whatever I divided by, I put in the front. So I will look again and see if there's any more factoring I can do, or if there's anything else that's in common in this binomial, but there isn't. So that's completely factored. And the process I did up here where I was factoring numbers is the same verb or factor or break down into a product as what we did with the variables. So I'm going to cut out that writing the GCF step for the next one, and I'm just going to figure it out in my head. I'm going to show division one more time, and from there on, I'm just going to kind of do that part in my head. So looking at these two terms, the GCF is 5 for the numbers, There's no y in common, so that's not part of the GCF. And for the x's, it's just an x to the first. So I'm dividing by my GCF, greatest common factor of 5x. I put the 5x on the outside. Dividing in my first term, I have a 4y squared because the x cancels. And then my second term, the 5's cancel, I just have a 1, and x squared divided by x is just x. So I can write minus x or minus 1x either way. Looking at the next one, for this one, I have the two terms. I'm going to figure out the GCF in my head. So for 10 and 25, that's 5. For x cubed and x squared, the lower power of x is x squared. So I'm taking out a 5x squared. That's my GCF. Here I'll have a 2x left, and here I'll just have a 5 left. So I showed that without dividing, but if you need to, you can write in that division each time so you can see what's going on. Moving on to my third one, this looks more intimidating because there's 3 variables, and maybe try this one, pause the video and try it. But basically, we're still doing the same thing. So 10, and then this is a 1, so we're not going to divide really by a number. It doesn't really have a numerical GCF other than 1. For the x's, it's just x. For the y's, it's just y. And for the z's, it's z cubed. So this is a 10x z squared left here. And then my other one, since these match completely, basically it gets all divided out, but I still have to have something there. Something divided by itself is 1, and since we have the negative sign, it's negative 1. So looking at the next one, it says usually we completely factor expressions, right? I didn't just look for a common factor on that section. I looked for a greatest common factor, the biggest thing I could take out. So for example here, I could have just taken out the x squared and left the 5 in here and had a 10 and a 25, but that wouldn't be completely factored. So this next question here, it says, but there are many ways to partially factor as well. So now it says, which of the following is not equivalent to 20x squared minus 30x? So of these 4 answers, 3 of them are at least partially factored, and 1 of them is just wrong. So I'm actually going to start out and factor it completely. So looking at 20x squared minus 36x, my GCF would be 4x, leaving me with a 5x in the first term and a negative 9 for the second term. So I want which one is not equivalent. So this one is equivalent, right? That's what I got. So then I'll start to look at the other answers. So number 1 actually could be an answer, because do you see how just the 4 is taken out, but they left all of the x's in? So that one's good, right? That's right. So I'm not going to pick this one. Looking at this one, we could have just taken out a 2, not a 4, which would have left this as a 10 and this as an 18. So that looks like it's good. So I'm just going to multiply this one out to make sure it's the one that's not right. This would give me 20x squared, but here I would have minus 320x. Basically, this 20 and 16 add up to 36. They don't multiply to 36. So this is the one that's not equivalent. The next section, the next section is just a little bit more practice with GCF, except we have 3 terms. Nothing has really changed. I just have to check 3 different terms for a GCF. So here I just have a number or a constant to take out because there's no x in the third term. So I take out a 2, and I have x squared plus 4x plus 5 if I divide each of those terms by 2. So this is my final answer. Maybe try the next 3 by yourself and then check the video. In my 3 terms here, I take out a 5. Leaving me with 2x squared minus 10x, and don't forget that plus 1. On my next one, we actually do have an x in common because all 3 terms have an x in them, and it's just x to the first is my GCF, as well as a 4. So I take out 4x, and I have 2x squared minus 3x plus 5. Last one, GCF would be 3x, so I have 2x squared plus 5x minus 7 left in parentheses. And just as a preview, sometimes those trinomials would factor further, but we haven't really gotten there yet, so I didn't set up so that any of these are something we're going to look at right now. But do realize this is sometimes just the first step in factoring. So let's look at the next page. That'll be in a different video.